In this video, we will look at cross-sections in more detail. So here is section CC that was mentioned in the previous video. The top drawing is the typical cross-section as it was presented in the drawing set, while the bottom photo is what they actually built. The writing on the drawing is a bit small, so you may want to use the drawing set on Moodle. The cross-sections are on drawing 10317-01-RD232. You will see the sheet numbers at the bottom right of the drawing. The typical cross-section shows more information about the road, including the width of the whole road, the width of the carriageway, bike lanes, footpaths, and the planted area. Zooming in, we can see that it also tells us how wide the bike lanes and carriageways are, the camber of the road, the type of surfacing to be applied, the depths and type of subbase and base course layers, the type of under-channel drain, and the required strength of the subgrade. Note the text is short and concise with some abbreviations. For example, DIA is the diameter, which is the inside width of the pipe. AC Mix 14 is a type of asphaltic concrete. Note they specify a chip seal is to be laid first. CBR is California bearing ratio, which is a measure of the strength of the subgrade soil. We will be looking at all of these materials in other videos. The depth of the subbase and base course layers is also part of the design process. The subgrade and pavement supporting the road need to be designed to resist traffic loads. These loads are not just the weight of the vehicles, but also the lateral or horizontal forces from vehicles accelerating, turning, and braking. We'll be looking at a simple pavement design method used for urban roads in the pavement design course. More detailed design using complex calculation methods may be used for roads with heavier traffic loadings and speeds, but these complex designs are not part of this program. The width and layout of the road is usually guided by local council design guidelines. These guidelines can be called engineering standards or codes of practice. They provide guidance on what the council would accept for a road designer, but the road designer usually has the flexibility to alter the widths and other details to match the road use and location. These drawing extracts are from Chapter 7 of the Auckland Transport Code of Practice. You can see it provides good guidance on the widths of the various parts of the road. The road we are looking at has similar dimensions, but they altered some of the widths to match the road location. For example, our sample road does not have parking as there are no houses accessing that part of the road, and there is no road for the berm, so the footpath is next to the curb. The bottom drawing shows the locations of services for the road. This drawing set in the Council Code also has drawings showing the layout of cul-de-sacs, traffic islands, vehicle crossings, as well as dimensions of different types of curb and channel. Other sections of the code have other details on most of the other features in the road reserve. I suggest that you Google your local council's code of practice or engineering standards and have a look at it, because they are very useful documents when you're doing design. Many drawing sets also include detailed cross-sections at every chainage point. The drawing set on Moodle did not need them for that project, so I have used cross-sections from another project. The project I used had chainages at 50-meter intervals because it was for a forestry road. You would have chainages at 20-meter intervals for urban roads. The drawing set had a drawing like this for each chainage point, so we are only looking at one cross-section of many. This cross-section has information on the levels of the road. Levels are the heights of land above a set level called a datum. The most common datum is mean sea level, which is the average level of the sea over the year, but other datums can also be used. The vertical distance of a point on a land surface above the datum is called a reduced level, or level for short. So when we say that a piece of land has a level of 15.5, we mean that it is 15.5 meters above the datum. Datums allow us to relate the levels of all points on the land to each other. This drawing shows the cross-section at chainage 50. Under the chainage is the annotation datum 14.000. which means that the line underneath it is 14 meters above the datum. The drawing at the top is a scale drawing of the road, and the vertical lines show points on the cross-section where level information is provided. Below the datum line is a table setting out details of these points. The bottom row is the offset, which is the distance of that point from the road centre line. The centre line here, as you can see, has an offset of 0. The point to the right is 2.75 meters, which is 2.7 meters to the right of the centre line. This drawing uses negative value for points to the left of the centre line and positive values for those to the right, but really this is not required. It's just the distance that's important. Jumping to the middle row, we have the existing levels, which is the level of the ground before the construction starts, which is shown as a dotted line on the drawing. The next row up is the design subgrade level, which is the level that the subgrade needs to be at. This level is shown in red on the drawing. So at the offset of 2.75 meters to the right of the center line, the existing ground is at a level of 15.61 meters, and the subgrade is at the level 15.86. So we need to fill in this area to lift the ground level up 0.25 meters. The top row is the design base course level, which is the level that the surface of the road needs to be at, which is shown as a green line on the drawing. At our point at an offset of 2.75 meters to the right of the center line, the design base course level is 16.09. The subgrade is at a level of 15.86, so we need to lay 0.23 or 230 millimeters of subbase and base course to bring the road surface up to the required level from the subbase. You will note that the difference between the design base course and design subgrade levels are all about the same, as the depth of the subbase and the base course levels are the same across the whole width of the road, and indeed along the road as well. Note that the camber for this road is 6%. This is because it will not have a surfacing and is an unsealed road, as it is only required for forestry traffic. The steeper camber is required as runoff moves more slowly off an unsealed surface.